prefabricated sustainable factory that produces prefabricated sustainable homes. I'm going to start about a little bit about the future of building construction. As I see, if you think of a car and how it's built in a factory versus if that car was built how a house is built, where you bring all your materials on site and you construct it out in the ultimate elements and in the rain, and you expect the same performance criteria of that car if it was built inside of a factory, you wouldn't get the same thing. So, kind of the same thing with houses. What I think we'll be moving towards in the future as far as housing is a kind of living machine that facilitates the human's well-being, not give them a sedentary lifestyle where they just sit around and do nothing. The house does everything for them, but the house actually tracks their living situation better. So with that, this factory here, and it is located in Prairie, Texas, which is near the Dallas area. The site is right next to Great Wolf Lodge, if anyone knows where that is. One thing about modular housing is that there are about approximately 8 producers of modular housing in the United States, most of which do mobile homes, some of which do actually architecturally design prefabricated solutions. And so we definitely need more prefabricated solutions if that turn is ever going to happen. So prefabricated modular houses have seen a rise of 12% over the past 5 years. So people are just kind of slowly crawling into the boom and expected within the next 20 years or so. And so with my thesis project, I kind of have a personal relation to residential architecture, because that's definitely where you engage architecture in the most intimate of ways. And so to be on the forefront of that design, technology, and business aspect of residential construction, I chose this factory as a thesis, so I can hopefully one day own my own factory in-house with a design firm in-house. So going towards my vicinity plan, the reason I chose Texas, specifically Grapevine, but the reason I chose Texas is it is in the middle of the country. And so if you weren't trying to ship modules to the country, the fastest place would be to do it from the center so you can spread out. The site I have here has a railroad line, so you can ship houses that way. It has a mixed master of Texas 121 and the International Parkway, which loops into pretty much all of your interstates, so you have easy access to get into another state from that point. And also it's located in a kind of industrial district. Over to the left you have large freight companies that have 18-wheelers that ship freight all across the country, so you have a deep transportation hub in that area. Also, you have a grove of trees that are a product of a river that flows along the site, which is kind of central to my concept, which I'll get into a little bit later. But yeah, so moving to my site analysis, strictly the environmental data. The biggest thing I picked up from this analysis was the sun pattern. So I used the curvature of the sun's pattern to map the form of my building, because the roof is all photovoltaic, and so you get maximum solar capacity from mapping this direct path and facing south. Contextual data. My building is pretty much off the grid. There are some grid connections just in case if there were to be any sort of failure, but I also have backup generators just in case for that as well. Along with my concept is flow, which is definitely taken from the river you see across the site. It is a primary line of circulation from water, and from that primary line you have product that is produced from that line. And so it kind of, you plan, it moves to the building because you have a primary line of circulation, and the product is produced from that line, which is the facility itself and the product is produced. So in section, the use of flow is reference to the different strata of the earth. So you have the 3 strata. You have the lithosphere, biosphere, which people, plants, and animals live at, and then you have the stratosphere, which where the clouds and everything else is. So I kind of took it into a material analysis with the sectional property. And so the plinth, which references the lithosphere, is made of all mineral-based materials. So concrete, limestone, et cetera, et cetera. The middle portion, which represents the biosphere, is made of all organic material, so mostly wood. And also there's a reference to the humans that work at that level. So you have all organic beings or things that work as materials now. So, and then at the top, references to the stratosphere is made of light metal that dances across the various planes and filters light like a cloud. It's also painted white, and also the material properties of how metal is made originally sought its genesis from inquiries of the cosmos, trying to turn metal into gold. So, onto my site plan. As you can see, primary line of circulation, we have parking in that threshold between the primary line and the building itself. You have roughly 50 parking spaces, 40 employees. I did a code analysis, which I'll get to a little bit later, that only specified that I have 20 or so parking spaces, but with the employee count to produce the amount of houses that we're trying to produce with this facility, I had to increase that number. So the loblolly pine, which is this tree here, is used as the column structure to reference back to the forest. And if you see in my material study here, it's rough, unfinished, much like this. So it has a direct tie back to the forest. So when you look through that glass and you see the column here, glass threshold, forest, there's a connection in between. Also, the site itself sits on a valley, and all the water slopes to that river there. So that's how drainage is taken care of. On my floor plan, just I'm not gonna say a brief walkthrough because there's like 60 points of space. But so you enter through here, find your parking spot, come along the ramp. The factory itself is elevated 4.5 feet. So when you meet the loading docks, you meet the height requirements for loading and unloading material. So at this entry port, which is a covered porch on the south side, you split and go to your designated areas. Like visitors will go towards the visiting area where they're met by the secretary's desk to facilitate their needs. Also, the architectural studio is in right proximity with that to introduce collision between the designers and the clients, or the potential clients, which will be the visitors, so they can talk about architecture. And so you have service spaces that service that area, small bathroom for the people waiting, conference room, things of that sort. And then you also have your design studio, which holds 8 staff of 8, and they also have their own print making room and model making shop towards the rear there. If you're an employee, and also there's a view to the factory towards the finished product. So the architect always has a visual connection of the end product and what they should be designing towards. So it kind of helps them, form their module systems a little more efficiently. And so if you're a staff member, you would pass this small gathering space here I have under the covered porch, and then you enter through a security key card entry that wouldn't be access to the normal public. And then you would pass by the owner's office. The reason the owner's office is so close is because each employee passes every day to foster relationships to the people who own the company towards the people who work for the person, because I feel those relationships help foster a better company. And so with that daily interaction, that person who owns the company knows the face and name of each person who works for that person, which I feel is very important. And so you also have your accounting office and your marketing office, and you have your main bathrooms here. This whole section here is elevated 3.5 feet. I did a study on elevated views, so the supervisor can see across the 100-foot factory floor. Even though you still have tall houses, you have a little bit better view of monitoring employees to make sure they're working efficiently. Also, I have this catwalk back here, which has 2 purposes. One is for the operable catwalk, so the roofers can get on top, lift the plate and the grate, and shingle the roof, and also for the supervisors to stand on an even more elevated level to get that view shot across. Here you have the paint storage room. A little bit about air conditioning. This entire southern bar is the only air-conditioned space. The northern bar is openly ventilated. The factory portion is pushed to the north because the northern light, also with the roof shape, you get all pure northern light, so they have the best light for the best working surface, and so they can produce more efficiently with better light, with less, with a more comfortable space. So if you are in the clothing, you run past this, you check in your materials into your, you check in your tools in your locker, and you go to your assigned workstation. Here I have a small break room, and so you can go there during your breaks, and it has a small recycling center. No cooked food, just small, prepared items. And yeah, so the workflow of the product, I found in my research, I went to Ground Force Systems in Navasota, and mostly what you have nowadays in prefabricated architecture, they'll make the wall units of the house, and then they'll flat package, ship it out to the site, and erect it on site. But some companies pour the slab in-house, build the entire structure, break it apart, shrink wrap it, and send it out, which I didn't know was an uncommon thing because I had that in mind when I first stepped into this project. When I went out to the site, they said not many people do this. So that's interesting. So that's what this factory does. So the concrete truck will pull in here, back into there, pour a slab of concrete, then you shift it on these in-ground tracks that move the slab throughout the space. And so you have a portion where it can dry here, a portion where it can cure there as well. And then it's moved into the building where you have the framing tables. Here's the roof framing table. So they'll erect the frame of the roof. And then you have the wall framing table. They'll erect the wall frame, which is managed by a derrick crane that it's not cutting that section. But there's a derrick crane that runs through this portion of the building to place that roof on top. That is also serviced by a mill. So a delivery truck will come in with raw materials, and they'll be stored here, cut down at the mill, and then stored as finished, pre-finished product, and then shipped out right towards the table to be assembled. Then after the framing is assembled, you go towards rough mechanical and plumbing, and it's serviced by this the storage bar here, which is a light metal fence. Where you have all of your electrical wiring, all of your basically things that are tools like your nuts, bolts, and everything, and it's serviced just within this bar. So your employee wouldn't have to walk around here every time they needed to get something, so you can have a more efficient workflow throughout the workday. Then you would shift over to your envelope assembly, where people will put on your roof, shape, siding, things of that nature. And it's also serviced by this bar here. All the service bars that service each zone pretty much hold all of your nuts, bolts, etc., etc. But when it comes to exterior and interior finishes, they're stored on this mezzanine level here because they have such a demand for space. So after that, after everything's all the finishes are put in, the appliances are installed, broken apart into ports. I based this layout from the LVL house by Rocio Romero, and so the dimensional properties are taken from that house, but the usability of having different types of architecture is there. So it's basically shipped out through here. So what you have is an assembly flow in this direction purely. So you have raw material imported through here, finished material exported through here. Code review. I did a fixture count. All the fixtures are up to code. All the railings are up to code, and so on and so forth. Thorough code analysis to make sure everything complies with code. Structure. I have the lob-lolly heavy timber columns. Some people kind of give me a face when I say, I have heavy timber, then a steel, roof on top. That has been worked out per the structural engineer in the detailing, and it all works out, which I'll get to later. But so what you have are your loblolly pine unfinished columns with your custom truss on the top, custom recycled steel metal truss on the top, and then you have SIP panels that span throughout that truss to make the structure for the roof system. Here in my programmatic breakdown, you have the factory floor, which is comprised of this bar here, the entry that splits off the users towards their designated spaces, your visitor center to facilitate visitors. When I went to the factory that I took precedence from, they didn't really have a center catered towards visitors. It was more of a production facility. But if you're to run a company housed in one facility, you need to facilitate potential clients, to make money. So that is really played up by providing a double volume space that is naturally lit, that feels comfortable for people to sit and wait and talk about the house they would like to get. Storage here is facilitated mostly along the northern bar, which service the workstations here. The core spaces, which are all your MEP requirements, are pretty much kept towards the southern bar. Here you have, okay, so with the mechanical, electrical, plumbing diagram, we have your electrical rooms here. You have your pad mount transfer, your main electrical room, 2 secondary electrical rooms. With stormwater drainage, you have your roof drains every 56 feet. And so what you have is you have a curve in this direction, but then the roof is also broken and slopes 1/4 each way. And then all the excess waters, but most of the waters, all of the water is picked up from the interior roof drains and carried down to a precast concrete drainage ditch that goes into a man-made wetland that overflows into a reflecting pool with a cistern in the bottom. So yeah, that's that here. Plumbing basically just shows all the rooms that we need: exhaust, waste management, and plumbing. Heating and cooling, I have my 2 750 gallon chillers that chill the water for the cooling of the space. Then you also have your primary, your boiler room here, which heats the water that services these hot water heaters that are placed throughout the core of the space to help keep it warm during the winter. And so these overhead doors here, during the summer and other hot months, would be constantly open during business hours. And then these switch action louvers would flip open, and then the fans would draw air from the overhead doors and out through the roof. Telecommunications, I have my main distribution frame, and then two secondary distribution frames. Waste management, I have my spot for recycle bin and the trash collection unit where dumps can easily come in, back up, grab the trash and leave. Also, I have dust collection for the mill. I have a dust collection machine outboard, and it services these 6 sawing stations where you grab all the sawdust and put it appropriately so it doesn't interfere with the air quality of the space, because I find that to be very important. My main focus for the entire project was to make it the best place for someone to work, because with the construction methods we use now, we put people out in the harsh elements, out in the harsh sun for hours and hours and hours upon end. Now, I mean, that can be good or bad depending on what kind of person you are, but I prefer to be in air-conditioned space while working out. So, with that, I have emergency power, which are my 2 generators here, just in case of the photovoltaic array didn't catch enough solar energy, which I highly doubt because it's very long building, and even the photovoltaic aspect of it is just kept towards the center because you wouldn't need it for the whole span. So, but that's just in case. You want to keep things rolling just in case you run out of power. Towards my section here, which is cut right here, looking this way, you have your concrete piers, grate beams, slab. The slab is made of high fly ash concrete which is recycled from a local coal plant. And then you see your connections for the columns to the truss, as I was talking about, which you would have 4 U-shaped pieces, and the column will be milled to receive those pieces, and then they're bolted towards bolted through the column and welded to the truss. And you kind of have the same thing going here at the sole where you show you the detail, where you have a steel soffit, which is anchored by 2 anchor bolts, which are put in the concrete and then welded to a steel plate, which is connected to the anchor bolts. So here you have high voltage LED lights instead of halogen lights, because I did a little bit of research on that, and I hear LED lights and high capacitor coming up nowadays, and that would be a good alternative to halogen lights. Here you see your mezzanine storage up above, where it will hold pretty much just your finishing materials, and that will be accessed by a crane, by a forklift. Here you have the air conditioning cell. If you can see sectionally how I manage air conditioning within a small contained unit, and everything else is openly ventilated. You see your catwalk, and then you see your drainage system coming down slowly into an underground pipe towards the cistern, which goes towards this, towards the cistern. So my cladding for the building is a reclaimed tongue and groove set at 45 degrees on the exterior, 45 degrees on the interior, so it makes a structural diaphragm to help with the load from the roof. Also, at every vent point, you have a recycled material made by a company called DeQuales, and so they have a recycled fabric that filters the air as it comes out of the vent, and so you have pure air quality into all of your
no, that's like how much memory's left.
conditioned spaces. Okay, so here my sectional diagram pretty much just explained what I just explained, which is the air coming through the roof, the natural ventilation, daylight coming in through that same portal, slab and hot bias concrete with administrative views, fire suppression, which takes water from an emergency cell from the cistern. So the cistern only uses so much water, and then it keeps a certain amount for emergencies for the fire system. Stormwater collection, overhead storage. Here's a inside metric of the building, and it's here's an entry here. And then here's the flow that's on the building. You have your hot fly ash slab with your reclaimed walls, and then you have your Pioneer 1600 UT Series 2 curtain wall, line column, custom steel truss, and then you have your roof system. A little bit about the roof system. It is a Timberline manufactured steel, structurally insulated panel, which has mop-down roofing for the mechanics, the maintenance people who will walk across and service the photovoltaic panels and clean them every time that you clean and service and walk upon. And then in these splits here, you have your switch actuators, and your fans also sit within that space. With the roof system, there's a fairly new third generation photovoltaics where they can actually screen print on material. That is interesting. I didn't know about that. I thought it was very interesting. So I'm using copper and screen printing on the copper towards the center. And so towards the center you would have the copper, the screen printed photovoltaic, and then a thin, I want to say polyurethane film on top to so the rust. So when it does age, the film doesn't get interrupted. But on the exterior, you wouldn't have that covering. So over time it would weather and in turn it would beautiful weather green on the sides. Here's an interior rendering of the factory floor. You see how the fans sit within this portion here to blow out the air. The mullions are green to once again reference the bio layer. They have a reference towards the needles that the loblolly pine grows, which are, I want to say that exact green, but I'm trying to catch as best as I could. Then you have your air vapor membrane, and then you have your sit panel underneath, which sits on top of the custom truss. Also, you have your curb condition here, just because we don't want water to flow over the louvers and into the space, so you have a curb condition to keep it sloping towards that drain. Here's the Conair 1600 detail. The detail for the in-ground trench. So you have a bar grate on top of that, which is walkable, and then you have your underground pipe that leads to that drainage, and then you also have the in-ground track detail, which is basically just poured with the concrete, and so the rollers fit within that, and you can slide it across easily, like pushing it, two or more people. And you also have your exterior rendering of the entrance. Here is a small material sample of the concrete for the slab I would use. Here is the structurally insulated panel, recycled fabric, massing model, which is more towards accentuating the direction of flow. And that concludes my presentation.